A rotary compressor uses a rolling piston within a cylindrical housing to compress vapor against a reciprocating vane. The spring above the vane holds it in contact with the rolling piston at all times, providing a vapor-tight seal between the high and low-pressure zones within the compressor. The rotary compressor requires only one valve, the discharge valve. Compression and suction occur simultaneously on opposite sides of the rolling piston, so it takes 2 full revolutions of the shaft to draw in and compress a volume of vapor. Let's start with the rolling piston at top dead center. As the eccentric shaft rotates the rolling piston from top dead center past the suction port begins to open and a space begins to form between the vane, the rolling piston, and the housing. With continued rotation, the volume of this space increases, reducing the pressure below the low side pressure in the cycle. Vapor is then drawn in through the suction port. This continues for a full revolution until the compression volume is filled with suction vapor at low pressure. During the next rotation, the suction port is blocked by the rolling piston. The low-pressure vapor is then compressed in the space between the rolling piston, housing, vane, and discharge valve on the other side of the piston. Initially, the discharge valve is closed, trapping the low-pressure vapor for compression. Continued rotation of the rolling piston along the inside of the housing reduces the volume of the vapor, compresses it against the vane, and raises its pressure. When the vapor pressure exceeds the high side pressure, it pushes open the discharge valve. Discharge continues until the rolling piston completes the full revolution and has expelled most of the high-pressure vapor. The discharge valve closes when the rolling piston reaches top dead center. Viewed from the end, the screw compressor has 2 helical, that is, screw-shaped rotors. One is a male thread, while the other is female. Their shape allows them to compress refrigerant gas as the threads of the 2 screws mesh. The compressor motor drives the male rotor, which in turn drives the female rotor. The design, pictured here, has 4 lobes on the male rotor and 6 on the female. Therefore, the male rotor rotates more rapidly than the female. This visual shows the movement of the refrigerant vapor from the suction to the discharge of a screw compressor, as viewed from the top. The vapor enters the suction area of the compressor and is trapped between the 2 lobes of the rotors and the compressor cylinder wall. Many designs use an oil injection system to seal the clearance between the rotors and the cylinder. The screw threads form the boundary separating several compression chambers which move down through the compressor at the same time. Only one such chamber is shown here to simplify the illustration. As the gas moves along in the compressor, the compression chamber is somewhat reduced in volume. This is the beginning of the compression process. The compression space becomes progressively smaller until the gas exits at the compressor discharge in its fully compressed state. This side view shows the overall pattern of refrigerant gas flow through the screw compressor from its suction to its discharge. Like the scroll, compression is nearly continuous and the screw compressor operates smoothly. Scroll compressors compress refrigerant vapor between 2 basic ports, the fixed scroll and the orbiting scroll. This arrangement does not require suction or discharge valves. Each scroll element is made in the form of spiral vanes fixed to a flat base plate. The vanes are formed in opposite directions so they can fit together. The fixed scroll is attached to the crankcase of the compressor. The orbiting scroll is intermeshed with the fixed. The orbiting scroll is driven by the compressor motor and moves within the fixed scroll, forming crescent-shaped pockets. Low-pressure refrigerant gas is brought in from the outer portion of the scroll. It is then squeezed into increasingly smaller pockets. By the time the refrigerant reaches the center, it is fully compressed and discharged. It takes about 2 complete revolutions of the scroll to move the gas from suction inlet to discharge inlet. In actual operation, the crescent-shaped pockets will contain gas at various stages of compression. Compliant scroll compressor designs allow the orbiting scroll to lift from its normal operating position temporarily if, during abnormal circumstances, liquid refrigerant enters the compressor.